Okay, we are continuing with June 2012. So let's look at number 33. We did this one. Let's go to number 33. This is a recursive sequence. We don't see too many of these, but just follow what they ask you to do. They start out giving you A1. So the first time around, A1 is 3. Okay, they want 3 terms in this sequence. So we're going to go to now when your K is 1, when you get your A1, and now we're going to go to when K increases. So we're going to put K as 1, and we're going to come up with A2. So it's going to pull in your original 1, because you're going to put a K of 1, which will make this say A2 now. And this is going to have the other 1, which is your 3, minus 1. This is going to give us 5. This is the second one to this. This is K is 1, K is 2, K is 3. Sorry, A is 1, A is 1, A is 2, A is 3. Okay, now, next time around, K is 2. So 2 plus 1, this is your A3. 2 times A of 2, which is your 5 that you just found, minus 1. You start, if you noticed, with the first one. It goes in here. Then you find a new one, and that goes in here. And that will find you this one, your last step, which is 9. This is the one they're looking for. Two sides and the included angle of a parallelogram. Draw your parallelogram. Two sides, it doesn't matter which one is which, and the included angle. They want to know its area in simplest form. Usually means you have a radical. Otherwise, they would tell you where to round. If you noticed, your parallelogram cuts into 2 equal non-right triangles. So you look up your formula for one non-right triangle. Since we have 2 of these, we're going to multiply this by 2, which gets rid of your fraction. So your area for your whole parallelogram is going to be AB sine C. So we're going to plug in 18 times 22. Now, sine of 60. You notice when you put this in your calculator, you get a decimal. They want exact value. So we take a look at your angle for 60. And we can see that your sine is a radical. The sine of 60 is radical 3 over 2. That's what you have to use in here. So 18 times 22 times radical 3 over 2. You've got to keep your radical 3 in here. So multiply your 18 times 22 and divide it by 2. 198 radical 3. That's what you're looking at. They wanted your answer in simplest radical form. Okay, here we have a trig function, and they want the equation. Now we look where it begins. If I look at the sine of 0 or the cosine of 0 degrees, I realize that the sine of 0 is 0 and the cosine is 1. So because it starts at the 0, I have a sine curve. And it will fit A sine BX. Here's your sine curve. with A being the amplitude, B is the frequency, how many curves occur in 2 pi, we can see that one curve occurs in 1 pi, therefore your frequency has to be 2. If your period is pi, and we want to know how many occur in 2 pi, I need one more. So your period is pi, your frequency is 2. Your amplitude is the absolute value of this distance, which would be -1, -2, -3. Your amplitude would be 3. Now, the reason it goes down first is a reflection. That gives you the negative. So -3 sine 2x. There's your equation. To check it, put this in your calculator, do a zoom trig, and remember, in your calculator, it's going to go to 2 pi. You're actually going to see 2 of these curves, unless you change your window to 180. You'll see 2 of those curves. Okay. This looks bad. This is just a beefy Algebra 1 question. We know that when we see a divide, it says keep the first part, change, and then flip this over. So we have this, I'm just going to rewrite this, flip it to a multiply when you flip this over. Now, your goal here is to factor everything. Here's your perfect squares. Here's a trinomial. This cannot be factored, and this one has a greatest common factor of 2. From here, we're going to have one big line, and we're going to factor out your common factors. I see an x plus 3. I see an x minus
Jordan
2.
McCallum, please report to the lower
And a
lobby.
2 minus
Jordan
x.
McCallum, please report to the lower lobby.
I see an x minus 2 and a 2 minus x. And what happens with this is, because they're exactly the opposite, if you take out a -1 out of either one of these, it will become the same as the other one. As soon as I get my pen working here. Okay, back on. So if I take a -1 out of here, I force this factor to switch around. Now I can take this common factor out and not lose my -1. So I've taken this common factor out. I have this one left, my -1. And I'll just turn that around to say x plus 2. And on the bottom, I have a 2 and an x plus 4. Now, if you want, you can leave it like that. I wouldn't mess with any negatives, it's just easier, but make sure that that has parentheses around it, because it includes both of them. You can flip it to the bottom, if you like. We'll do the least amount of manipulating with it. Keep it as simple as possible. Here's a nice one for standard deviation. Now, if you notice in this one, it talks about a company who surveyed all of its employees. All means we have a population. Some or part means we have a sample. But all is the population. We have 15 employees. You're going to put this information into your L1, and you are going to tell whoever's grading this test that you did this. And you're going to tell them the steps you went through. One Ver Stat L1 to find your mean and to find your population standard deviation. Remember to make it your population standard deviation. Now, from here, we're going to look at your standard deviation curve. Here's your mean in the middle of 40. Here's one above, one below. We add 14.9 and we subtract 14.9. So we want anybody that falls between 25.1 and 54.9. Now, you need to just go through and circle everybody that falls in between. Make sure you show work. This is your work. And then, because they asked how many, you're going to count these up. They wanted you to know, determine the number of employees. There were 8 employees whose time fell within 1 standard deviation of the mean. This is a nice problem, but remember to show your work on this problem. Okay. Number 38, it talks about a resultant and 2 applied forces. Remember with applied forces, we start here and we make a parallelogram. Here's your force 1 and your force 2. Make this a parallelogram. So your resultant passing through here is 27. It doesn't matter which way you set up your angles or your forces. I can call this one force 1, force 2. Remember, it's the same thing over here because it's a parallelogram. That's not going to matter which way you set that up. Because this is a transversal through 2 parallel lines, this one is 45, this one is 60. To find this missing angle, 3 angles of a triangle add up to 180. So 180. Okay, we're going to determine this by 180 minus the sum of these 2. And we're going to find out that this angle is 75. Always find the angles because you can always find an angle where you can't always find a side. So now, you can see you have a ratio right here. If you're looking for your F1 and your F2, you can see one ratio here for your log signs, and you can see another one there for your log signs. So you have 2 log signs to do. So 27 over the sine of 75, that's our constant, is the second force over the sine of 45. You're going to cross multiply, and you're going to remember to round to the nearest pound. So this force is going to be 20 pounds. You're going to do this again for your second ratio. For force 1, again your constant, 27 over the sine of 75, is your force 1 over the sine of 60. And your force 1 is going to come out to be 24 pounds. In this last problem, we have a nice exponential equation, but before we can set the exponents equal to each other, we have to have these in the same base. So we notice that they don't drop down to base 9, but they do drop down to base 3. So 3 to the 4th raised to the x cubed plus 2x squared, and 3 to the cubed raised to the 5x to 3. Once you have the base there, then you can set your exponents equal to each other. Be sure that you multiply your exponents out. So let's get those set up. This 3, I'm going to distribute distribute this 4, and we have a nice equation. Because this is a quadratic, get everything to one side. Not a quadratic, it's a polynomial. Get everything to one side and put it in descending order. And we're going to factor this. The greatest common factor here is just x. So let's take out the x. And then we can get it more manageable into a quadratic. So x is going to be 0. That's one of your roots. Then you're going to factor this. And it factors to 2x minus 1, 2x plus 5. Set those equal to 0. Set this one equal to 0. And make sure you give your answer, and then make sure you check them all. These should work. If you struggle with this factoring, pull this off to the side. Do the A times C method. It really works well. 4 times a negative 5 is going to give you negative 20. I want factors of negative 20 that are going to add up to 8. If you have to start going 2 and 10, blah, 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 you'll figure that out. So we know that we have 2 times 10. And we want it to be positive 8. So a 10 times a negative 2. That multiplies the negative 20 and adds up to positive 8. So we're going to take this out and replace it with 10x minus 2x. So 4x squared plus 10x minus 2x minus 5. And group. So we're going to factor out a 2x. And we're going to be left with 2x plus 5. And notice we have this, but it's the opposite sign. So we're going to pull out a negative 1. And here's our common factor. 2x plus 5 times 2x minus 1. Those were your factors we used. And there is your regents.